So yeah, so I'll take you through some of the steps in how FeatureCAM handles bringing in projects and getting through the typical workflow and automation the way FeatureCAM does it. It's very flexible, by the way. There's some things that are rigid. There's some rules to follow, so we'll go ahead and um, go through those. And this is what you'll see when you're first opening up FeatureCAM. Some of you, if you've already used FeatureCAM, know what this looks like. It's the first page you see. It's going to ask you what type of process are you going to do? Are you going to be doing milling, turning, Swiss, vertical, mill turn, or any of the other options that are available here? Ask you a few upfront questions like what units of measure you're going to be using. If you're wanting the wizard to help you out, FeatureCAM is very wizard based, so this actually helps you a lot with going through the steps in automation within FeatureCAM. So I like to keep it on, and then you can make your own custom machining configurations. This will help you to capture that knowledge from the last job or the last few jobs you've had and put them into a configuration that you can use over and over again as time goes on, and kind of refine that to make it easier to go through jobs into the future. Now, I'm going to load a document here, and really all that is you're going to open a machining document in Fusion. This is the wizard here, and of course, the first thing it asks us to do is define our stock. I'm actually going to sidestep that. I'm going to finish because what I want to do is I want to import a CAD model, and that's the CAD model I'll bring in. It's a simple step. Now, if I look at this in 3D, it has a few features on it. There's some three-dimensional as well as some two-dimensional features there. And again, FeatureCAM is wizard based. So the first thing it asks us is if I want to use the wizard to establish my orientation of the part. Of course, if you've designed it in the same orientation, it's going to be machined. A lot of times you won't have to do this, but it's always good to be able to have a little bit of help to align the component if it's been designed, say, in aircraft space or within an assembly where it's not oriented the way you really need it. So I'm going to go through the wizard here. All it's going to do is ask me how I want to align my Z. I'll do that here. I'm just going to pick a straight edge on one of the corners of the part and go through the steps to align my X as well. Pretty easy so far. And as I'm going through the next steps in the wizard, this is helping me define my setup, right? So we've aligned the orientation of the part in the way we want to cut it. Now, what we want to do is create some stock around the part, right? So typically a component like this might be already machined around the profile of the component itself. We're just going to really do some machining on the features. So I can actually enter stock dimensions of my own that I know I have, or I can use the model to compute my stock, and that's what I'm going to do. I won't do any offsets to the X and Y, but I do want a little bit of meat at the top, assuming that we're going to do some kind of basic operation. So I've defined my stock pretty simply by creating stock based on my model and doing a little bit of adjustment. So again, that flexibility that you have there, even though there's some automation, there's also quite a bit of flexibility. Next thing I want to do is just make sure that I have a origin point for my offset that's going to match what's on my machine. I'll pick the center in this case. And then I want to decide if I'm going to be doing any kind of multi-axis machining. So for this, it's pretty straightforward. It's mostly 3-axis if we want to keep it that way. So we'll go on to the next step, and that's it, really. Our wizard allows us to go ahead and get through that process really quickly. Now, if we look at the part again here, we have our origin. The axes are aligned the way we described them, as well as the block, which is kind of outlined there in the blue for our stock. Now, if we wanted to go through and do what we traditionally do in other software, for instance, create some tool path for facing or for creating some of these pocket profiles, we could do that manually. That's something that FeatureCAM does allow you to do. And in the features and manufacturing section here, the toolbars, we do have the ability to create features on their own, one by one, whether it's from dimensions, from curves, from surfaces directly from the model, but we also have what's called AFR, or automatic feature recognition. This is probably one of the best I've seen in the industry, really. I've used a couple with some so-called feature recognition. FeatureCAM by far beats out all of them in the ease of use and the amount of recognition that it actually does with your models. So what's going to happen here is when I select AFR, FeatureCAM is going to ask me which body do I want to use for recognizing these features. Of course, I only have one body here, but if I had, say, a vise in here or maybe some fixturing, it's going to recognize those as models. And I want to make sure that I only recognize features from the cut model, the component that I want to actually place toolpaths on. So that's the model that I'll select. Going through, it's also going to ask me if I have multiple setups, which setup would I like to add these features to. Of course, again, there's only one here, so I'll go on to the next step in my wizard. And here, pretty quickly, FeatureCAM has recognized all of the features within my component, and it's put them in a list here. It's also named them. And if I go through and scroll, I can kind of pick and choose which ones I either want to leave in or I want to take away if I don't want to add them to this portion of my programming workflow. I actually want to make all of these features. So I can go on and select finish here. And you can see it blinked really quickly. It looked at all of the tools that I have in my defined tool library. It looked at the features that were selected on the part automatically, and it placed toolpaths in it with all of the predefined step overs, step downs, feeds and speeds, and tools, again, based on the model, the tool library that I have selected, as well as some machining attributes that I've either predefined or that come loaded with FeatureCAM from the start. If we look at our browser here on the left-hand side, we kind of scroll through and see all of the features that have been created. Now, on the right side in the operations list, this gives us a view of all of the individual toolpaths within those features. So I can kind of scroll through and you'll see them highlight in our main view there. And I can pick and choose those as well. I can edit them from this, but I also get other things that are really, really helpful, like these warning signs. Now, this is not stopping me from running this set of toolpaths, but it is giving me a warning saying, hey, you know, we couldn't find the exact match for a tool for this feature as it's described, so we chose another one. And it may be a little bit smaller. And that's fine. For a spot drill, I don't mind if it uses a smaller one, as long as it gets me a nice spot and I can drill through in the future operations. And I can scroll down again, going through the list of operations that it created for me. Now, this is a lot. Typically, if I would program this in most any other software manually, it would take me possibly hours to go ahead and pick through each of these toolpaths and features, apply a tool, give it feeds and speeds, and so forth. We were pretty quickly able to get through this set of features and get a finished part. Now, I always like to make sure that I do a simulation to make sure that the toolpaths are doing what I need it to do. And for that, I'm going to go to the Home tab and select to make sure that we're viewing this in three-dimensional space here instead of wireframe. And I can run through the simulation. Another good thing about FeatureCAM is warnings like this. So basically what this is telling me is that some of the operations are going to be reordered according to some rules that I've made in my machining attributes. Machining attributes is something I talked about earlier. These are a set of rules that I've predefined saying which operations can go first, how the operations are actually going to function, and just my preferences overall on how I want to machine components with certain operations. I'll show you that here in a little bit, but I'll go through the simulation for now. Now, I did allow the feature recognition to do some 3D machining, so some surfacing. That's why you saw that progress there, progress bar at the bottom, showing that it was calculating 3D toolpath. Now, again, some warnings that come up here, possible gouge, and it looks like there's the gouge there, and what's happening here is that looks like a center drill has gone before a pocket's been created for some of those lower holes. So let's take a look at that. I'll pause the simulation, come down. Yeah, it looks like those holes there are being, or at least attempted to be, spot drilled before this pocket has been created. So how do we deal with that? We can go to our Features and Manufacturing tab, come here to our machining attributes that I talked about, and this is the list that I was mentioning where you can define how certain operations get handled within your feature recognition, or even overall when you're creating toolpaths. So we have options to set for pretty much any operation here: drilling, pecking, milling. The one I'm looking for, though, is operations. And this is just to define how automatic operations get dealt with. There's 4 options here that I can toggle on and off. And the one that I'm looking for is to make sure that I'm cutting the higher operations first. I can set that to be on. And while I'm here, I can also do things like do those finish cuts at the end. So as you can see, as I'm checking these on and off, my operations list is automatically adjusting itself to suit the options that I'm selecting here. So if I do operations, finish operations last, my operations list adjusts itself. It's not really creating any additional toolpath. What it's doing is it's reorganizing the toolpath that I already have to make sure that it's safe and that it actually follows the rule that I'm placing here. So again, I can do that for a lot of other options and how I create toolpath within the machining attributes, and I can save those for reuse later. The other great thing is that I can share those with other programmers in my company, right? So if we're all trying to be on the same page, make sure that we're cutting consistently from part to part in the same way, or at least on the same machines and programs, we can share between us these machining attributes, and it'll drive consistency throughout your shop. So now that I'm done with the changes that I made in automatic options there, say okay, and I can rerun my simulation. Again, it's going to let me know that there's some rules that it's going to follow. And now what I see is that all of the operations are organized in a way that is going to be, first of all, safe, but also that are going to follow the rules that are in my machining attributes. Now, once I run the simulation, it's pretty quick, and I can go through the tabs here in my results window, and I can see that I have code already. So I can go to the machine with this program and know from the simulation and the toolpaths that I've created, as well as the tools that I've selected in my library, that I'm going to be able to machine this pretty quickly. So I've been talking for about 10 minutes now. And of course, there was a lot of talk, a little bit of action there. But imagine trying to, again, program this the traditional way without feature recognition. Again, there is the ability to do that in FeatureCAM, but this feature recognition makes it very easy and very quick to be able to produce programs at a fast rate to get your components on the machine and get them cut quickly. So again, this code is ready to go. I can go ahead and save this. I can output it. I can bring it to my machine, and I can get going with my setup right away. If there's any adjustments that need to be made, let me go ahead and get out of the simulation. You can see that there's some small icons here in the operations list that let me know, again, what issues there might be. Some things I may want to take a little bit of a further look at. So again, I can go directly into the toolpath here by double-clicking in my operations list. I can find the exact operation that I think might need some additional attention, and I can modify any of the parameters in the toolpath that I might think can use it, right? So it takes you through all the drilling attributes. Not only that, but it also allows you to go ahead and select other operations within that feature. So the feature is actually made up of potentially various toolpaths. In this case, it's made up of 3: a spot drill, a drill, and a counterbore. So I can go into the other parts of that component as well in the feature, and also modify any of the parameters within that toolpath as well. So it's a heads-up way to manipulate or edit any of the toolpaths. It gets through very, very quickly, and it's automated, which is the best part. Now, if there's anything that you may not like, so for instance, if I'm running my simulation and I happen to notice, well, let me run that just a little bit slower, come back here. If there's any operation, I think maybe, for instance, that pocket may be taking a little bit too much off of the material at the same time, I could go back in the toolpath and change it manually. But again, going back to the machining attributes, this is one of the great parts of being able to have these machining attributes, is that in milling, I can set different parameters here for accomplishing my pocketing in a better way. Right? So there's a long list of things that I can change there. If I need to do things like tricodial slotting, I can change the percentage in the tool diameter of the step over that it takes, as well as step distance. Lots of other things that I can do here within the machining attributes that are just going to help me refine my programming. And as I go along, I can get through with less editing in future programs, or even this one if I need to change those right now. As you saw, the operation list updated when I made those changes. Right, so that was automatic feature recognition in a very, very high level way. As I mentioned, there's other ways that you can machine in FeatureCAM. The options there, at least for dimensioning, are pretty straightforward, but this will, the creating milling features from dimensioning is a very quick and easy way to create features without the need of 3D CAD or even geometry. So for instance, if I wanted to place, say, a feature, a hole, a slot in any part of my current design, I can do that without having anything other than the dimensions that I want to have that feature be. So for instance, if I just needed an extra hole for possibly pulling this large heavy piece with a crane or lifter, I could do that by creating a hole from dimensions. Now, here I can just choose the type hole that I want. Maybe I want that to be a tapped hole. Oh, pick that one more time. And it gives me all of the options to create that hole and the features of that hole based on things like standards, my depth, if I need a chamfer at the top, and so forth. So let's go with something that might be a little bit robust. So maybe half 20 there. Pretty typical. I'll do a slight chamfer. Maybe that's too big. Give it a depth of an inch. And so I've described my hole here. I can go on through the wizard, and now I can pick my location. You see, the first location that's chosen there is the center position, right? The XYZ center. I can shift using my values here in X, Y, and Z. And I can also choose a position using the button here anywhere I'd like to on my CAD model. So I believe we're about 8 inches wide. Let's go with 3 inches here. And I'll go to the top view to make sure I'm not going to be too far off. We'll try to center it on the edge there. And again, I'm going through the wizard. This is kind of helping me. If I'm not really sure what I got to do next, the wizard's going to help me do things like choose if I want to actually create a spot drill or not. If I just want to do a drill, I can do that. And then take me through the rest of the steps. Now, I just noticed something here. I didn't position it well in the Z. I'm going to have to go back there and make sure that I have this in the right Z position. Let's get less. Yeah, we're good there. So again, going through the wizard, it's also automatically chosen the tools that I'm going to need to achieve this threaded hole. Now, it doesn't seem like it found a 1/2-inch drill though, or a drill that's going to be sufficient for creating this threaded hole within the library that I selected. And that's fine. It's going to actually create that operation and all the other operations or toolpaths that it's going to need to create that feature. But it's just giving me that warning that it wasn't able to find a drill. Now I'm going through the steps here of looking at the tools that it's chosen automatically for me to create this feature. At any one point, I can say either use the default tools that you've chosen automatically for me, or I can search for another one manually, whether it's in the tool library that I have right now or another tool library that I might have available. So I'm just going to go ahead and let it go through and choose the tools. Interactively, I can change the feeds and speeds or go with the ones that are already created when the tool was created, as well as the coolant. And so it just takes me through each of those tools. I can finish here knowing that all of these are already preset well, and I don't have to go through the steps in the wizard. But again, if I want to make any changes to a tool, I can do that. Looks like it's asking for some kind of drill. So we'll go and try to search for a drill that matches somewhat closely to our tap. Make sure I choose the right one. This drill. And I think we can get away with something like 50 here. And I'll go ahead and finish just to show you there. Okay, so yeah, we have the drill here that's missing. This is the one I want to go and change. Sorry, I selected it earlier, but I did not apply it. So let's go back and do that. And I think I wanted this 450. Gonna apply it and say okay. Great. Now, again, without any kind of actual CAD data or drawing or even geometry there, I was able to create that feature pretty simply using mill feature from dimensions. Right? We see it there. It comes in at the bottom of our list, as well as it gets fitted into our operations list, right? And it's organized the way it needs to be in that order. In other words, it's not going to be created before the pocket does. It's not going to be made before the facing gets done. It's going to come in the order that it can, according to my rules. Now, that was features from dimensions. We also have the ability to create things like features from curves. For this, there's a little bit of more work that needs to be done, but it's very discrete, right? When I want to be very particular about how I'm creating my operation, I can use things like mill from curves. Now I will have to, again, create my curve. So I'll go ahead and select a curve first. Maybe I want to select and create a curve from a surface here. And I'll chain it, right? I want to cut a profile around that bottom radius there. That's curve 105 in my list. Say okay. Now when I want to create my side feature with a curve, it automatically understands that I want to create this feature from the curve. I didn't really do anything after selecting side feature from curve, but it does want me to select a curve. And that's going to be the one I just created there. It's going to add it to my list. I'll go through and again, in the wizard, define how that feature is going to be depicted here. So I'm going to say it's going to be an inch tall. I want it to go an inch deep. The bottom radius is, it picked it out, it's 1/8. Although we are going to have to bring it in a little bit. We'll do some offsetting in the toolpath once it's already created. And here it's just asking me whether I want to rough and finish it as well. It's already been rough, so I'm going to leave that out. It's chosen a tool for me. I can examine the tool and make sure that it's going to be the right one for what I want to do. Change feeds and coolant if I need to, and then finish the process. Now, it brings up our our properties list for that particular toolpath, because if I want to make adjustments that weren't available to me when I first created that feature for my curve, I can do that here. Now, I mentioned that I'm going to have to do a little bit of offsetting, so I'm going to go ahead and do that now when I'm negative 1/8, and set that just so I know it goes all the way up to the wall. Say OK. And now when I run my simulation, we're going to see that that toolpath comes in at the very end. It's a finishing toolpath, or actually it might come in somewhere in the middle, and create that feature there at the bottom. There might be some more adjustment that I want to do, either to that feature or to other features. And I can use the same process that I just did to make sure I get through and finish this component exactly the way I need it to be. There we go. We saw that feature get cut. It's nice and smooth. If I needed to, I can go back and change the step down on that finish toolpath as well. By the way, that is a 3D finish toolpath. If I look at the side of this part, there's a draft angle on those bosses. So those are being finished and was automatically created using AFR. The toolpath for it, I'm sorry, the feature is here, and the toolpaths are in the operations list. Earlier, I went and selected the toolpath directly from the operations list, but know that in the part view here, you can also select and go to the properties for that feature, and you'll see the same window as we got earlier when we selected from the operations list. Here in the finish toolpath, millings tab, I can select the incremental depth that's being used in this finish toolpath. Now I need to go ahead and set that and apply it. And because this feature actually created the finishing toolpaths for all 4 of those bosses, that application of the step down is going to get applied to each and every one of the boss profiles that's being machined with the same tool. We can see the finer step down. It is taking a little bit longer, but that's because of the step down that we chose. Right? It's a larger, sorry, it's a smaller step down, and so it's taking its time to get through each of those surfaces and make sure we have a nice finish at the bottom there. Great. Now, what if I wanted to mill those using another type of strategy, right? There's 2 ways of doing this. Either I can edit the current strategy in the same way I did with going into the operations list or the part view and editing the toolpath. However, if I haven't created those just yet, I can use mill from surfaces here. And mill from surfaces gives me a lot of options in how I want to actually mill a feature. So let's pick one that we haven't done just quite yet. And I'll add surfaces. Got to pick them first. Let's see, we want to do these here. It adds my collection of surfaces that I chose, and it highlights them in green. This is the part that I wanted to show you. Now, again, there's some automation happening here. If we choose it to be, we can create a roughing, a semi-finish, and a finish operation in one step, or we can choose to apply a single operation. Now, we've already done the roughing and some of the semi-finishing for this feature, so I'm just going to pick single operation. When I go to next, I can choose from a long list of finishing toolpaths for this feature. Now, the one I want is a Z level, so I'll select that. But there's quite a good list of types of toolpaths that I can use. The type of toolpath that you select, by the way, is going to be based off, obviously, your preference and how you want to cut it, but also the feature shape, right? If it has undercutting, if it's sloped, if it's a ruled type surface, all that other type of stuff is going to come into effect. Again, we're doing a roughing operation. We can allow for certain things more discreetly within this way of creating this feature, right? So some of the automatic feature recognition actually creates this type of feature, but it will create it without setting some of these more discrete settings. In this way, we can go through and do in a bit of a more manual way or more discrete way how we want to actually cut this part. So we can add in things like undercutting, if we want to do some kind of continuous spiral. If we're doing some remachining, we can also add those parameters in there. Get a long list of ways to do some remachining. And again, going through our wizard to make sure we hit all the touch points that we want with regards to how we want to cut this feature. This one deals with how we want to roll over corners. If we need to create a slightly larger stock to make sure we get full cleanup, or if we want to add boundaries and contain the tool path. And then if we want to create a limitation on slopes. So again, a lot more that we have control over in that way. We've chosen a tool. I think that is a good one to go with. I'm just going to go ahead and finish this out. And again, because I have more control, I can come back into my tool path and I can refine things. One of the things that you may want to add in a feature like this is the ability to check the surfaces. So we have our part cut surfaces. Those are all there. Actually, our list goes on to show all of the faces that make up this entire model, but it's only chosen the ones that we've selected for cutting. Now, if we want to add some surfaces that we don't want to touch, or we don't want this particular operation to touch, we can either select them from the list and check them on, or we can highlight them on our model, go to the list to make sure that we find them what we want. Looks like it, yeah, there it is, and it there. So I want to stay away from that. I'll say okay, and then I can add in tolerances here to make sure that those that toolpath is going to stay away a certain amount. Finishing up that process, now that's part of my toolpaths. And again, I always like to make sure that I simulate to ensure that I'm getting what I want. And every time I simulate, by the way, it updates my NC code. You can see at the bottom, as we're seeing the simulation, at the bottom tab of the results menu, the NC code is grayed out, and it's going to highlight again when the simulation has gone through and checked every one of the toolpaths and made sure that there's no collisions, there's no gouges, and it's safe to run. So let me go ahead and speed that up so we get there a little quicker. All right, so now that we're finished with our operations, we see the NC code is updated. At some point within that set of toolpaths was my additional hole that I created, the additional side feature from a curve, as well as the finish feature from the surfaces that I select. So all that has been updated. Again, me talking for about the last 20 minutes here, I happen to get a lot done within this component, along with edits, changes to the way I was actually creating toolpaths, different ways I was managing those toolpaths pretty quickly within FeatureCAM. Now, again, these types of operations with automatic feature recognition, creating features from dimensions, features from curves, and features from surfaces are all available in milling, as well as in turn and turn mill. Right. So if you happen to be running turning centers, the automatic feature recognition is also available in there. And the same controls apply as well. Now, let me take you a little bit further into how the automation works in the background that we're looking at here, and where it's kind of pulling information from. This is the control that you have for automating in the way that you like to cut. And that's going to be all here within the materials as well as in the options. The machining attributes that we just selected and edited. Again, it has a long list of things that we can choose from: drilling, how our pecking operations are actually going to perform, our milling operations, step overs, which is one of the things we talked about. So if you happen to find yourself cutting lots of a certain material, you can apply that within the tool itself, but also here in the machining attributes. How ramps get dealt with, things like coolant. We touched on operations a bit, but we have options for thread milling, surfacing, the way surfacing leads in and out, the way tools are selected. Those are options in there as well as facing. And that's all for milling. Of course, as I mentioned, if you have machining attributes, you can apply into your turning operations. And when they're combined in mill turn or turn milling, those also get combined from the settings that we have here. Once you're done with the settings that you like, or as you're updating them, again, you can save those using save machining configurations, and you can share them throughout your company, whoever is programming, so that everybody's on the same page with the style of programming that you want to do. When we're looking at materials here, these are also things that you can set your milling, drilling, turning, wire EDM attributes to. So these are things that can be saved along with the machining attributes that are going to help you really get through jobs quickly and know that they're going to be machined in the way you want. Feed optimization helps you optimize feeds while you're going through toolpath. And if we look at some of the other options here and things like tool mapping, this is really going to help you organize the tools in the way they're actually positioned in your machine. So we've created a tool library, and each of the tools has a number identifying it. However, that might not be the number that is actually in your machine. So for instance, my first center drill there, that's tool number 1, and it kind of goes in chronological order as I've chosen them. But if for any reason any of these are just not in the pocket that I typically use in the machine for that particular tool, I can change it here. I can change and make all of the other offsets the same for by diameter, the length, and so forth. The other thing is I can save that back to my tool crib so that when I use that tool again, it's going to come up with the same number as I just set it to. Now, I've spoken a little bit about how those tools can be managed. But if you look at the bottom right corner of the screen there, this is going to be where you see everything from the post-processor that you're using, if you're using some kind of machine simulation model, and then also the tool library. For now, I just have a few basic libraries that I have selected, but anytime in the process, for instance, as I mentioned earlier, there was one tool that wasn't available, I can switch through into another tool library and manage that, or manage to select a tool from the other tool library. I can look at in several different ways what those tool libraries are, the way that I've named them. Usually you want to be discreet about that and name them in a way that makes sense to you. Maybe it's by machine number or machine type. Maybe it's by material, so forth. Great, so we've gone through 4 of the different ways that we can quickly get a part completed and programmed within FeatureCAM. Just to review, We can do, as we did earlier on, AFR, automatic feature recognition. The other thing is, even if you don't want to do automatic feature recognition to your whole part, you can do what's called directed feature recognition. And directed feature recognition really kind of goes through your features, just like we saw on the list earlier when we were doing AFR. And we can kind of look at what we want to include or exclude within our automatic feature recognition. So if at any point I wanted to say, I don't want to recognize any holes in my feature recognition, at least for now, I can check that off. If I do want to look for holes, I can set a diameter as a maximum of the holes. In other words, how big do I want to go with a drill, right? If the cylindrical feature is more than 1 inch in diameter, then that's going to be a mill feature. It's not going to be a drilled feature. That'll be added on to the way we do pockets or side features and so forth. When we are looking at holes, do we want to find any hidden holes? And this could be holes on the back of the part, or maybe undercut holes, those kinds of things hanging maybe under eaves or other things like that in features on the part. We can find those as well. Include partial holes. These would be holes maybe hanging off an edge. And then making all holes created in a constant C. So all of these features here, we can adjust. This is basically the settings that automatic feature recognition uses to find features on your components. So again, the ease of automation, but also a lot of control in how that automation is actually functioning with the way you want to find features on your part, as well as the tools that it chooses and the parameters to things like step downs, step overs, and so forth. For each of these types of feature creation, you do have several. Now, some are limited to two-dimensional or hole making, things like mill from dimension. Of course, a lot of times it's going to have to be described manually, like I did earlier with the tapped hole. So there is a set of features that you can create. That's actually pretty extensive. Rectangular pockets, slots, step overs and bores, thread milling and facing. And you have some of the same things when you're looking at creating features from curves, although the list changes to include a little bit more complexity in the types of features you can create. And then when we're getting into surfacing and creating features from surfaces, the list can get pretty complex in the types of features that you can create. The other thing is that feature recognition also works for multi-axis toolpaths or types of parts, I should say. If, for instance, I would have a feature or features on the side of this part, automatic feature recognition would absolutely be able to identify those features and create the setups that it's going to take to get to the sides of the component and do multi-axis operations like holes, pockets, as well as surfaces. So we're running up into about 10 minutes left here. That is my kind of run through of automatic feature recognition and adding some automation into your programming workflow, quickly getting results so you can get on the machine really quickly and get on with cutting chips and making money.